Determining electrical system requirements begins when there are no electrical prints available. It's necessary to make assumptions based on comparable projects. It may be beneficial to consult with other electricians, architects, or industry experts to gather information and estimate the electrical load. To do that, firstly, determine the building area. Find the square footage of each floor and the total building area. Secondly, consider occupancy. Estimate the number of units and the expected number of occupants. Thirdly, consider electrical appliances and equipment. Take into account the types of appliances, lighting, and equipment that will be used in each unit. When it comes to a conceptual design, the proposed system layout is generally acceptable as a starting point. It's also important to consider the following additional factors. Firstly, service entry. The service equipment, which includes the transformer, disconnect, and panel, will need to be located outside the building in an accessible and protected area. Secondly, vertical distribution. The panel inside the building will feed a vertical riser that distributes power to each floor. Thirdly, floor distribution. On each floor, a transformer will step down the voltage to supply individual units. Fourthly, metering. Meters can be located in a central location on each floor or within each unit. To gather inspiration and ideas for single-line riser diagrams, consider the following resources. Firstly, the National Electrical Code, also known as the NEC. The NEC provides general guidelines and requirements for electrical system design. Secondly, IEE Standard Number 241, Electric Service and Equipment for General Use. This IEE standard includes recommended practices for service entrance equipment. Thirdly, consider the Electrical Design Guide for Commercial Buildings. This guide provides detailed information on electrical systems in commercial buildings. Fourthly, online resources. Consider the Electrical Engineering Forum at https://www.electricalengineeringforum.com/plc/forum/18395 Electrical one-line diagrams. HTML. Fifthly, look at the library of single-line diagrams at https://www.antits.com/viewthread. CFM KID equals 130,362. Once a system layout has been conceptualized and the electrical load has been estimated, you can proceed with the following steps. Firstly, consult with the builder and architect to verify and refine any assumptions. Secondly, prepare a preliminary estimate based on the proposed design. Thirdly, discuss the estimate and any potential alternatives with the builder. Fourthly, if necessary, adjust the design and repeat the estimation process until everyone is satisfied. To elaborate on the electrical service for a multi-unit dwelling, let's consider some key aspects. The main service typically involves a transformer to step down the high voltage from the utility company to a usable voltage such as 208 volts or 120/240 volts. This transformer is often located outside the building in a secure enclosure. From the transformer, the power feeds into a main disconnect switch, which allows the entire building's electrical supply to be shut off for maintenance or emergencies. This disconnect is usually placed near the transformer. The main service panel, located inside the building, receives power from the disconnect. This panel distributes power to various sub-panels throughout the building. A vertical riser, consisting of multiple conductors and conduit, carries the power from the main service panel to each floor. This riser is a critical component for distributing power efficiently throughout the building. On each floor, a step-down transformer reduces the voltage to the level required for the individual units, typically 120/240 volts. The transformer is placed in a dedicated electrical room or closet. Metering can be done in several ways. All meters can be placed in a central meter room on each floor, or each unit can have its individual meter located within the unit or in a nearby accessible location. The NEC provides guidelines for service entrance requirements, including conductor sizing, overcurrent protection, and grounding. Article 230 covers service entrances for buildings. IEE Standard 241, also known as the Grey Book, offers recommended practices for designing electrical systems for commercial buildings, including service entrance equipment. For a 51-unit apartment building, it's important to accurately estimate the electrical load to ensure the service is adequately sized. The load calculation should include lighting, receptacles, appliances, HVAC systems, and any other electrical equipment. NEC Article 220 provides methods for calculating branch circuit, feeder, and service loads. It is critical to consult with the local utility company to determine their requirements for connecting the building to the grid. They may have specific requirements for metering, disconnects, and transformer placement. Remember that safety is paramount when designing and installing electrical systems. All work must comply with the NEC and local electrical codes. Use qualified and licensed electricians to perform the installation. Single line diagrams are essential for understanding the electrical system's layout and operation. They show the path of electricity from the service entrance to the individual loads. These diagrams are helpful for troubleshooting and maintenance. The NEC contains many tables that provide guidance on conductor ampacity, conduit fill, and overcurrent protection. For example, Table 310.16 lists the allowable ampacities of insulated conductors rated up to 600 volts. The equipment grounding system ensures that all non-current carrying metal parts are properly grounded, providing a path for fault current to return to the source. This helps to prevent electrical shock hazards. NEC Article 250 covers grounding and bonding requirements. The overcurrent protection devices, such as circuit breakers and fuses, protect the electrical system from overloads and short circuits. These devices are selected based on the ampacity of the conductors they protect. NEC Article 240 provides requirements for overcurrent protection. Coordination studies are performed to ensure that overcurrent devices trip selectively, minimizing the extent of an outage. This means that the device closest to the fault should trip first, while upstream devices remain closed. When selecting conductors, consider the ampacity, voltage drop, and environmental conditions. Copper and aluminum conductors are commonly used in electrical systems. NEC Chapter 9 contains tables for conductor properties and conduit fill. Proper labeling of all electrical equipment is essential for safety and maintenance. Labels should identify the voltage, amperage, and function of each component. NEC Article 110.21 covers marking requirements. Regular maintenance and inspection of the electrical system are crucial for ensuring its continued safe and reliable operation. This includes checking connections, testing overcurrent devices, and inspecting grounding systems. In summary, designing the electrical system for a 51-unit apartment building requires careful planning, accurate load calculations, and compliance with the NEC and local codes. Consulting with experienced professionals and utilizing available resources can help ensure a safe and reliable electrical system. Here are some additional considerations for the electrical design. Firstly, emergency power. Consider providing an emergency power system to supply essential loads during a power outage. This could include lighting, fire alarm systems, and life safety equipment. Emergency generators or battery backup systems are commonly used for this purpose. Secondly, lighting control systems. Implement lighting control systems to reduce energy consumption and improve occupant comfort. These systems can include occupancy sensors, daylight harvesting, and dimming controls. Thirdly, surge protection. Install surge protection devices at the service entrance and at downstream panels to protect sensitive electronic equipment from voltage surges. Fourthly, electric vehicle charging. Consider providing electric vehicle charging stations for residents. This is becoming increasingly popular and can be a valuable amenity. Fifthly, communication systems. Plan for communication systems such as telephone, data, and cable television. These systems require dedicated wiring and equipment. Sixthly, fire alarm systems. Install a fire alarm system that complies with local codes and standards. This system should include smoke detectors, heat detectors, and audible alarms. Seventhly, accessibility. Ensure that the electrical system is accessible to qualified personnel for maintenance and repairs. Provide adequate clearances around equipment and clear pathways to access points. Eighthly, future expansion. Design the electrical system with future expansion in mind. Provide spare capacity in panels and conduits to accommodate future loads. Ninthly, coordination with other trades. Coordinate the electrical design with other trades such as mechanical, plumbing, and structural to avoid conflicts and ensure a smooth installation. Tenthly, documentation. Maintain accurate documentation of the electrical system, including single-line diagrams, panel schedules, and equipment specifications. This documentation is essential for maintenance and troubleshooting. Let's delve deeper into the specifics of calculating the electrical load for each apartment unit. The NEC provides two methods for calculating the general lighting and receptacle load. The first method, the standard calculation, uses a demand factor of 3 volt-amps per square foot for general lighting and receptacles in dwelling units. The second method, the optional calculation, is typically used for new or heavily loaded services and allows for a more detailed calculation of the load. To accurately estimate the appliance load, consider the nameplate ratings of all appliances that will be used in the units, such as refrigerators, stoves, dishwashers, and washing machines. The NEC allows for demand factors to be applied to appliance loads depending on the number of appliances. For example, for 3 or more appliances, a demand factor of 75% can be applied. The heating, ventilation, and air conditioning, also known as HVAC load, is typically the largest single load in an apartment unit. The HVAC load can be determined by consulting the equipment nameplate ratings or by performing a detailed calculation based on the building's heating and cooling requirements. The NEC provides guidance on calculating HVAC loads in Article 220.50. It is essential to consider the diversity factor when calculating the total service load for the apartment building. The diversity factor accounts for the fact that not all units will be using their full electrical load at the same time. The NEC allows for demand factors to be applied to the total calculated load, depending on the number of units. After calculating the total service load, select the appropriate size transformer, service entrance conductors, and overcurrent protection devices. The transformer should be sized to handle the calculated load, with some allowance for future growth. The service entrance conductors must have an ampacity equal to or greater than the calculated load, and the overcurrent protection devices must be sized to protect the conductors. The grounding system is a critical component of the electrical system, and it must be properly designed and installed to ensure safety. The grounding system provides a low impedance path for fault current to return to the source, which helps to trip overcurrent protection devices and prevent electrical shock hazards. The NEC provides detailed requirements for grounding in Article 250. Surge protection devices, also known as SPD, are designed to protect electrical equipment from voltage surges caused by lightning, switching, and other disturbances. SPD should be installed at the service entrance and at downstream panels to provide comprehensive surge protection. The NEC provides requirements for surge protection in Article 285. In addition to the NEC, there are other standards and guidelines that can be helpful in designing the electrical system for an apartment building. These include IEE standards such as the Grey Book, which provides recommended practices for designing electrical systems for commercial buildings, and ANSI standards, which cover a wide range of electrical equipment and components. It is essential to coordinate the electrical design with other trades such as mechanical, plumbing, and structural, to avoid conflicts and ensure a smooth installation. This coordination should begin early in the design process and continue throughout construction. Finally, it is essential to maintain accurate documentation of the electrical system, including single-line diagrams, panel schedules, and equipment specifications. This documentation is essential for maintenance and troubleshooting and should be kept in a safe and accessible location. By following these guidelines and consulting with experienced professionals, it is possible to design a safe, reliable, and efficient electrical system for a 51-unit apartment building.